recording software. Never mind about that. Yes, sir.
Right, can we initiate with the class?
Yes, sir.
Remember the situation given to you. This is a question which featured in IIT. It was given to you that there is a disk. So this is a disk. You may assume that disk is placed perpendicular to the plane of green board.
Yes, sir.
Okay, it's bearing charge Q through and through. This is the situation. Okay. There is a string over here. Now, check the figure, please.
So could you explain the setup again?
This is a B field which is vertically upward.
Yes.
There are two strings to which a disk is connected.
Yes.
Disk is bearing charge Q.
Okay.
And we rotate this with an angular speed omega.
Yes, sir.
Separation between the strings being given to you, D or L, will happen with increasing omega. What will be the observation you make if you keep on increasing omega?
So the axle of the disk is a rod.
Yeah, it's a rod. It won't conduct electricity.
Okay.
It will not let charge pass through it because disk is insulated, yet there is charge Q strewn on it, uniformly placed on it, let me say.
But the disk is free to move left and right.
Not left and right. It can rotate in the plane perpendicular to the green board.
Yes.
Okay, the orientation of disk is perpendicular to green board.
Yes.
And it can rotate in that plane perpendicular to green board, whereas rod and strings are housed by green board.
Yes.
Okay, dear. This rod is housed by green board. This rod, this string, they are housed by green board, and this is disk to you, which is made to rotate as I move my hand.
Yes, sir.
This is how it is made to rotate. Okay.
Yes. So if you did the V cross B formula, ideal cross B formula, you'd get that there's a force acting to the left on the top of the disk and a force acting to the right and on the bottom part of the disk. Right?
Okay.
So that would suggest the rod would tilt in the plane of the board, but I can't envision how that would happen because the strings wouldn't allow for that.
Well, from where are you getting current?
Oh, it's not charged?
Yeah, it is charged. It's being rotated as well.
Yes, so that would imply a current.
Over indicative of current. If you're indicative of current, then current will take a circular orientation.
Yes.
So what do you mean by the top and bottom? You get it.
Yes, sir. If you consider the top and you consider a current element.
Okay, element at the top and element at the bottom.
Yes,
right?
Sir. And if you applied the normal ideal cross B formula,
correct,
you would get that the top of the disk experiences a force to the left and the bottom of the disk experiences a force to the right.
Okay.
Is it? Okay.
What is it? Is it to rotate L cross B? If you take L cross B, right? L is, let's say, towards me.
Yes, sir.
And the top or the pinnacle, L is towards me.
Yes.
L cross B, if I take, that you get it to the other side, to the left, and the
Yes.
other will be right. That means this dish should start rotating this way, correct?
Yes, sir. That's my hypothesis.
Okay, this way, if it starts rotating, then what will happen to tension in the string?
So that was my question, because right now I don't think it's allowed to rotate in that dimension.
No, it is not, but they have gotten you maximum bearance of 3 T naught by 2. If T naught is organic, by
Yes.
organic I mean when there is no rotation made,
Yes.
mass is m of, let's say, disk.
Yes.
So T naught is basically mg by 2 is what they mean.
Yes, sir.
And was gotten maximum bearing by one of the string, whichever it may be, is 3 T naught by 2. That's given to you.
Yes.
Maximum that it can be, the maximum that can sustain. In that case, as you have indicated, it will try to rotate. If it's trying to rotate, then which string is susceptible to break?
The left one.
Left one is susceptible to break. Can you tell me then, with this rider not to exceed 3T naught by 2, what can be the maximum omega allowed?
Yes, sir. So I think we can, a simple torque calculation would suffice.
How will you calculate torque?
Um, okay, so to. Alright. Okay.
Cross B would, yeah.
So to calculate the torque on the. First, we need to calculate the torque on the disk. So, I mean, there is a simple formula. There's a formula for that, right? M cross B, magnetic moment cross magnetic field.
U cross B, yeah.
Yes, but then we'll have to find the magnetic moment first. This is a disk, not ring.
Yeah, that is simple. Mu is not difficult. Mu is I into area.
Yeah, so we'll have to integrate that all the way from the center to the outside.
Not required, no integration required. I we know, right? Area will be pi r square, of course.
So what would be I?
I will be Q in Q by T. T is 2 pi by omega, right? Because Q charge flows through. If you take in one rotation, what charge will flow through an area perpendicular to the orientation of disk? Q charge is flowing through it, correct?
So, but Q is the charge distributed across the entire disk, right?
Yeah. I am taking current.
Yes.
I'm taking entire of, we're talking of disk. Then you will have to integrate. Talk of ring, then there is no need to integrate.
Oh, we're using a ring? I thought we were using a disk.
If you're taking disk, then it's fine. Then you'll have to integrate, because you'll have to take mu for different rings, and accordingly will integrate, you'll get mu for it.
Yes.
So that is okay. If I'm to take it easy out here, and in consonance with what was asked in IIT, it was ring to me. So ring will be all the more easier for us to calculate mu. Correct?
Yes, sir, sure. So for there you could take mu to be I times A. I would be well.
Omega by 2 pi.
Sir?
I will be Q omega by 2 pi, correct?
Q omega by 2 pi. Yes, Q by T, and T is 2 pi by omega. Yes, yes. So that times the area, that's pi r squared. And that times the magnetic field, since they're at 90 degrees anyway, you can skip the sign. So if you cancel out the pi's, you get Q omega r squared B by 2. Okay,
so what do we do next? Mg, you can take weight, or m the mass of the ring.
Yes, sir. So right now I want to calculate the torque about the right pivot. It's not a pivot, whatever, the right end of the rod.
It's completely at your discretion there what you want to do.
Yes.
Which one you want to.
So the right end of the rod.
Even at first, I would say that if I am incorporating T1, T2 both, will be easier for me to get the final done. Because first equation out here, according to Newtonian classical mechanics equation, is T1 plus T2 is equal to mg.
Yes, but my idea is if we completely take T2 out of the equation, if by taking the right end of the rod as the point about which we calculate torque.
No odds.
Sir?
No odds with it. You can certainly go with it.
Yes.
T2 and mg will feature then, right?
Yes. So you'll have mg and the torque created due to the rotation and the other tension which we have to calculate. We can just solve for that.
Yeah, and you'll be getting their needful over here. Well, if I have to take T1, T2, then I get these equation. T1 plus T2 will be firstly equal to mg. This is Newtonian concept,
Yes.
right? And then I'm calculating to about this point per se, let's say. So mu cross B will be into the board.
Yes, sir.
I have to see from this side, just a minute. Mu cross B will be not into the board. If it is this way, then into the board. Let us take it this way, then better, right? Okay, I'm taking this rotation, fine.
Yes, sir.
Then mu will be this way, correct?
Yes, mu will be that way. And that cross B will be out of the board.
Mu cross B will be into the board,
So wait 1 second. Mu cross.
Mu is this.
Alright. Wait 1 second. Wait, mu cross.
Doesn't matter by the way, whichever way you take.
Alright, 1 second. Mu cross B this way is coming out. So the other way must be in. Yeah, sure.
Okay. This is mu, and mu is this way then, and mu cross B will be into the board. Okay.
Yes.
If I take into as negative, then I get minus of mu B, right?
Yes.
And this is T1. If this is T1, this is T2. Then which one will produce into the board torque?
So about what point are you calculating torque?
I have taken from this point calculation. This point calculation is what I'm into. So I got mu cross B, right? And my equation will feature both T1 and T2, right?
Yes, it will. You also will not have to deal with mg. So,
Yeah.
okay. So if you
mg
took
is already there in the first equation.
yes, if you took so if you took inward as negative, then T1 will be negative, T2 will be positive, right? Yes.
Okay, so what do we get it as? R cross F. So we can write it as minus of d by 2 if d is the total separation, which is what we are adding to. If d is the total separation, which is what we are adding to, then minus of d by 2 T1 and plus of d by 2
T2.
T2, right?
Yes, sir.
Is equal to what? Plus I into alpha. We are not allowing alpha, so 0.
Yes, sir.
Alpha, we are not allowing alpha, so 0. So these two equations are to get you omega, I presume, correct?
Yes, sir.
Which string would be susceptible to break here, dear?
The left one, right? Oh wait, you changed the direction of the current, the right one this time.
T1 or T2?
T2.
T2. So we'll get T2, and T2 accordingly will be placed for its maximum with a caveat. From there, we are to get what omega is allowed to the upper limit.
Yes, sir.
This one that feature. Let's move on to other question. Any question that you do have, dear?
Yes, sir. I do happen to have one question. Just 1 second, I'll fish it out. It's somewhere hidden in the depths of my Discord.
In where?
So okay, I can't find it, but I do remember the problem statement. There's it's
Can elude you. Questions can be elusive, is it? Can it elude you?
So no, I got the answer, but then I did it using a different method, or rather, my friend did it using a different method, and the answers didn't seem to match. So the question is, there's a wire carrying current that's going into the screen, and and there's a vertical surface, right? Starting from the horizontal line along the wire, and then going to a length A. It's also at a distance A from the wire. They wanted to calculate the magnetic flux through that surface.
Okay. So you listen, there is an infinitely long, let's say there is an infinitely long wire, straight wire, right? There's an infinitely long straight wire, is it so?
Yes, I've sent you a rough illustration I made.
Let's check it. Okay. So there is a wire which is infinitely long, and you have to calculate magnetic flux linking through the annular circle. Is it so?
So linking through the vertical line, think of that as a rectangular surface, the square surface with length, breadth, and height A.
Yeah. Okay. This one, A8 and alpha rotation. So this is a wire. I'm getting a number is there is a wire which is infinite on length. It is passing through the X that you have marked. And then what are these two circles?
So they're just as reference circles. You can forget about them. The main thing is that white line I've drawn. That's the surface. You will have to calculate the magnetic flux through that surface.
Okay, fine. So where you calculate magnetic flux linking to the surface going to the presence of infinitely long straight wire carrying some current. Okay.
Yes.
So this surface that you are referring to here, this surface is infinitely spread in one dimension. Is it so?
No, sir. It has a definite length A. It's a square surface.
That's pretty fine. And then what do? You cover it. You complete the square from sides. This is up. Similar length you can take down, right?
Yes, sir.
And you can take in other three directions as well, right?
Yes, sir.
Given A root 2, so I'm taking A down, I'm covering the cylinder at four faces. Can we be allowed to do that?
Yes, sir.
And if we are allowed to do that, then we know that the total flux is linking through the infinite stent. I am taking it to be a stretch of infinite.
Yes, sir.
See, what we can go ahead with, we can take a streak where it is infinite, or we can take a streak where it is finite, correct?
Yes, sir.
We are taking a streak in which it is infinite, okay?
Yes, sir.
In that case, we can calculate what will be the flux, correct?
Yes.
The flux linking can be easily calculated.
So, but if we assume your hypothetical surface which completely encapsulates the wire, then by definition the flux through that has to be zero.
No, it is not encapsulating because you're talking about infinitely long radius, so it cannot be encapsulated. What I'm saying is that it's enveloped.
So could you draw it just so that we're on the same page?
Sure. What I'm trying to suggest is we are referring to this position, right? And this is infinite too. Now what I did, I took this surface, and this surface is infinite to me in this dimension.
Yes, sir.
Okay. Then you have one to this side symmetrical and finite in this direction.
Yes, sir.
Then over here infinite, right?
Yes.
And over here infinite.
Yes, sir. So it does completely envelope it.
Yeah, it is enveloping, but you can't do it this way. You cannot cover it.
Okay, all right, but still my argument holds. The flux to that surface must be zero.
The flux linking through what surface you want? You want not through the entirety, right?
So the
I am calculating.
So the entirety would. So please continue.
No, please.
Yes, I'm saying if you were calculating for the entirety, we know it would be zero, right? It has to be zero.
But you are not moving on it there. You're moving in a circle, right? This is A, okay? And you have taken this to be A root 2.
Yes.
Okay. Now, Understood, yeah. Now what we can do, we want across this one, right? This is what you have asked.
Yes, sir. Flux through that.
Flux to this one. Now, the organic method, if you ask what can be done, is pretty simple. I'll calculate B at any point, right?
Yes, sir.
Let's calculate B at this point. B will be in what direction? We know it will be in this direction, correct?
Yes.
Okay. Now this is taken as R, right?
Yes, sir.
At this point, what will be B mu naught 4 pi twice I by R, correct?
Yes, sir.
Okay. I is the current in this one, right?
Yes.
So mu naught 4 pi twice I by R, right? Done. Now comes to you, what will be area? How can we get area? Area will be over here. Which segment area I'll have to take? I'll have to take this segment area, correct?
Yes, sir.
So what do? We assume this to be, let's say, y.
Yes.
Then small length become dy, correct?
Yes, sir.
So what is this small length making with this b? If this is theta, right? This will also be theta, right?
Yes, sir.
Is that? What do we get from here? Flux linking, small amount of flux if we are to calculate. What do we get? Mu naught 4 pi twice I by R. Okay, done. And into area. Area?
Yes, sir. So area would be r by cos theta. R by cos theta would give you the height in the sense, and times a to give you the into the board length.
Which area are you referring to, dear?
So the area of the little segment.
I'll take it dy. I'll take it dy into length L, which is infinite, right?
Yes, sir.
This area.
Yes,
correct?
I'm saying dy is r by cos theta.
Yeah, correct. It will be dy, but I write that down. Anyway, I have to calculate per unit length because area will be then infinite, right?
Yes, sir. So I think we can take it the same to be a.
I'm taking L over here, right?
Yeah, sure.
And as you suggested, y and tan theta relation, if I write, so tan theta is equal to how much? Y by a, right?
Yes, sir.
So y, as you are suggestive of, is equal to a tan theta, right?
Yes.
And dy will be a sec square theta d theta, right?
Yes, sir.
Now we can write flux per unit length. We will have to write. I'm taking per unit length, okay?
Yes.
Because if I'll take area, will be an issue with me.
Yes, sir.
Okay, there. What do we write over here? Mu naught 4 pi twice of the current and it by R, where R is to be changed as R is varying. So let us change R. What for R we can write? A by sec theta. Allowed?
Yes, sir.
A by cos theta. So A sec theta.
A sec theta.
Okay. This R to me and y dy. Dy is to be written. So A sec square theta d theta, right?
Yes, sir.
Now what? We are to integrate over sec theta d theta to get flux.
Yes, sir.
From where to where theta will vary is known to you.
0 to pi by 4.
0 to pi by 4.
Yes, just 1 second. Let me cross-reference this with my calculations to see if we've got anything different going on here. 2 pi. Sec theta d theta. Yes, sir, I've done the exact same thing. If you do integrate this, you get a slightly different answer from what's given in the answer key.
Okay.
So,
and where you got the answer?
Yes, sir, I exactly do not know. This question was given to me by a friend. It's from a book years ago. Although I think I do have a suspicion here. We took the magnetic field, we multiplied it with the area, but we forgot the cos theta resulting from the dot product, didn't we? I mean, that's what I'm thinking right now. Should we include that?
Cos theta, where did we forget here? Remind me. B dot ds.
Yes, sir. We took the value of b, we took the value of dA, but we didn't do the cos theta. We didn't write the cos theta, did we?
So B we wrote, area will be in which direction? Yeah, I mean, you are right, I presume. Because B we wrote, but area, we have taken area vector should be in this direction, right?
Yes.
Okay, so if area vector in this direction, then you'll get one more factor, which will be cos of 90 minus theta, correct?
Yes, the sine theta in that case.
Cos of 90 minus theta will be sine theta. I presume you're right. Yeah, that will be sine theta. But I have one more suspicion, which is slightly lurking. If you can clear over that as well. Here, area which we are referring to here.
Yes, sir.
Is this area, right? This area.
Yes, sir.
But as I move this way, then R will keep on changing this way, right?
But we are not taking it from a stationary point. We're moving the point of reference also along the wire, aren't we?
Then if we move it along and R is kept constant, yeah, correct.
It's infinite.
So
wires.
I think it'll be good. Yeah. Correct. So this will be the answer then?
Yes.
Check with this answer. There's yes incorporation.
Yes,
incorporation of sine theta is must. Sine theta should be incorporated.
Yes, I'll include sine theta. I think that gives us the answer.
That will be sine theta by cos theta, right? That means it is tan theta.
Yes, sir.
Tan theta d theta.
Yes, sir.
The integration of tan theta.
The integration of tan theta is I've forgotten the standard integral.
Tan theta sec theta, right?
So, no, tan theta differentiation is tan theta, right?
ln log it will come. Log
yes, sir, there has to be a log, and that's what I'm looking for. Integration of tan x is yes, minus ln cos x. Yes, sir, that should give us our answer. Yes, sir.
Minus by the way, this is a good integration of tan theta.
So yes, you do it by substitution, right? Sin theta by cos theta. You substitute cos theta for t.
Yeah.
Yes, so this
that when you will get the answer to this one, right?
Yes, sir. So there's actually another way to do this where you consider two circles. That's why I drawn the two circles, and you just consider the area of the segment between the circumferences of the two circles. And then you say that the flux through that white surface must be the same as the flux through the red surface, because the magnetic field lines are circular.
Okay, just a minute. Let me check the figure that you have sent. What did you say? Please come again.
Yes, sir. So we know that the magnetic field lines, the area, are perfectly circular, right? So from that theory, we can say that whatever flux passes through the white surface must also pass through the red surface, which is perpendicular to it.
Right. Agreed. Correct.
So you can, and that's a rather much more simple integration. If you do that, you get the right answer. Same answer.
Yeah. Basically, we are saying that this cone structure is a cone structure will be similar in proximity as the one, correct?
So your video is frozen, your voice is breaking. So, no, not properly.
Now here?
It's still distorting.
Okay. You guys switch on your video in that case. Better.
So could you come again?
Is it better now? No.
Yes, it's slightly better. I mean, I can understand you. I guess that's enough.
So your indicative of whatever flux is passing through the white one will be what is housed by the red ones, right?
Yes, sir. That's what I'm saying.
That's one kind of structure, correct? Isn't it? Yeah.
So I don't see how a cone would form here. I mean,
Correct. Could you please come again with the assumption? White one, same as?
the wire. So like there are two concentric coaxial cylinders. Yes, the two coaxial cylinders. So and now it's like we're calculating the flux of all the fluid flowing in between them. So my assertion is it doesn't matter what surface we take, as long as one end is on one cylinder and the other end is on another cylinder, the flux flowing through all of these surfaces should be the same, because the same amount of magnetic fluid is flowing through them.
Correct. So you are calculating the flux flowing through the concentric circles, correct?
Yes, so the flux flowing through the surface that passes through the wire, that's a lot easier to integrate and to find an expression.
Yeah. Can we take in that? So we'll be able to encapsulate it. That's the issue over here. Admin charge would have moved ahead with what was professed by me earlier.
Yes, sir.
In case of charge, we can cover it up, and
yes,
the flux will be, as you know, Q divided by 6 epsilon naught.
Yes, sir. We can do that with charge. Yeah.
Right. Any other idea? Any other question?
Say yeah. Actually, I do. Let me find it. Yes, I got it.
That pressure one you did try or not, Vasudev? The one which I didn't show, but I was suggestive of some finding pressure in this case by taking component. That one. So, for which we got answer as mu naught I divided by 8 pi square r square. In what? This was a thin walled cylinder and you had to calculate pressure.
Yes, sir. I think we solved that in class actually.
Yeah, we did it by two methods, but this was left when I asked you to take the component. I didn't show, that is what I meant. We discussed, we deliberated, and show the working. So, how did I pass the working? Yeah?
So, no, you didn't send it to me, although I do believe I derived it myself.
That's very
Yes, sir.
As a working.
Yes, I've sent the other question I have.
Yeah. Tell me the other one. This is the working weather. I'll send you it. You can check it out. There's nothing much over here. Okay.
Yes, you can send me a picture. I can't really read anything on it right now.
Come up with your question. Send me your question.
So I've sent it.
Two equal mass by a string of margin and two equal masses by one. Thanks over to ideal massless pulley as shown in the figure. Okay. The left mass is moving the vertical line. Left mass moves in the vertical line. But mass is free to spin left. Okay. As you start with the right mass, make a small initial angle of theta. Between two the initial length of the string on both sides of the pulleys are initial length are initial length of string. Both sides of the pulleys are around working part reach a length of L, capital L. Capital L is greater than.
So first of all, I'm in odds with the fact that the oscillating mass will go down. I say that the oscillating mass will actually go up. I don't understand how it would go down.
What makes you come to that conclusion that it should go up?
So basically, when both of them are hanging from the two pulleys, they also have the same mass. So the tension in the string is mg, right?
Yeah, but no. The string has got linear density here.
Oh,
the
okay.
string has got linear density. Tension will not remain same in string.
Yes.
Lambda L minus y into G, right?
Yes. As my point is, can we solve like a simpler version of this without the weighted string? I mean, it's pretty hard as it is without the string which has mass.
If you are taking without the weight, then of course it will move up. Then how will it move down?
Oh, okay, it will move up in that case. So why does the string having weight actually make a difference here?
Yes, we are calculating tension in the string, and tension in the string will be highest at the topmost position.
Yes, sir.
As we are moving up the string, tension will keep on increasing.
Yes, sir.
So tension, when you come to the topmost position, where the tension is varying, if the tension is varying, then what changes it is to bring about? What will happen to the center of mass? Center of mass will keep on moving, right?
Yes, sir.
Center of mass would have moved even with the bob, but center of mass will be all the more into motion more than the bob, because center of mass is positioned somewhere midways. Let us say not midways exactly. It'll be lower. It will be midways in the left one, but it'll be lower in the right one.
Yes, sir.
No, not even midways in the left one. Left one also will be somewhere low only, because for string you will get midways and mass is down, so they will be almost the same level to begin with. That is what being said. But when you swing, then the effective length of the right one will be lesser than the left one, correct?
Yes, sir.
So in that case, there will be an effect of mass of string. Had it not been, then it would have been identical case.
Yes, sir.
Let's say there is no, for example, let's say there is no mass, right?
Yes, sir.
And now you swing. If you swing, then what will happen in tension in the right one? Whatever is tension in the right one is to be then developed to tension in the left one. The string is one without a mass, right?
Yes, sir.
Okay. Now if we swing and it goes to the extreme up, where it stops, then we will write tension is equal to mg cos theta.
Yes, sir.
Okay. It has stopped momentarily there, and tension is equal to mg cos theta. Now, which is what is less than what it was earlier?
Yes, sir. So that was why I said the left mass would move down if it has no mass. If the string has no mass.
Yeah, when the string has got no mass to its merit. Now the string has got mass to its merit, let's say. Fine?
Yes, sir.
Now we calculate tension. tension again calculate at the mouth of Bob. Okay?
Yes, sir.
I get it again that T at the mouth is equal to how much? Now, how do we write T at mouth? Just at the position where the Bob is. T upward and mg cos theta again in that direction, in that alignment. So T is equal to mg cos theta there, correct?
Yes, sir.
But as you move up, what is happening to T? T is changing, correct?
Yes, sir.
So you have to see what T you get when it comes to momentary stop, what T you get at the pulley topmost position, correct?
Yes, sir.
If that tension is to balance the left one, then of course they are not to move. If that, because that is the tension which I'm getting the minimum there, right?
Yes, sir.
As we move up, we have to integrate and check what tension we get at the topmost position, pulley position. If that tension is less or if that tension is high, accordingly we'll come to a decision what is to happen.
Yes, sir. So the question professes that that tension would be higher than the left one.
I'm myself slightly in odds with why will that tension be high? What I'm getting is that tension should also be low than what tension is to the left side. So
Yes, sir.
how are they saying to be this way? I need to calculate if at all there is mathematical surprises to be checked. And what coming to me logically is that tension should be less than the left one. So it still is to move leftward.
Yes, sir. So you mean rightward?
That means the one which is vertical will move down.
Yes. It's
an replication of the previous case.
Yes, sir.
Yeah. But I'll recheck and see what is that making the author say the other way.
Yes, sir.
Okay. I'll check this.
Yes, sir. Sure.
Okay. Integration is to be checked. What will be doing?
Yes, sir.
Have you checked the integration? Did it integrate for it?
And no, sir, I just left it at the intuition. I was like, okay, this is baloney because you wouldn't expect it to go down.
The author should not be into baloney. They should be talking sense.
Yeah.
To be left over Rahul Gandhi. And if what else?
So okay. Yeah, this is other question. I don't know where he's getting these questions from. Possibly some book.
No, that's good. Wherever it's getting from doesn't matter. Yeah, we're not into source, but if the questions are to be authenticated and are good, then we should go for the solution.
Yes. So this one seems physically solvable, but I can't get myself to comment on its on the complexity or ease of its solution.
A thick stick of length L and mass M is initially held vertically, just shown. Initially held vertically, just above the horizontal rotating platform, the distance r from the center of the platform. Initially held vertically, just above the horizontal rotating platform, a distance r from the center of the okay, into the platform, which is rotating with the constant angular velocity omega. Okay, the coefficient of friction between platform and the surface is mu. The stick is released from rest. Determine the angular velocity of the stick when it reaches the horizontal position. So there's a stick which we are holding, mass M, length L, initially is held vertically just above the horizontal rotating. Will not conservation of angular momentum do? But how are they related to each other? Let me go to the drop of the case. There is given to you a stick, okay, which is held length L, mass M, initially held vertically just above the horizontally rotating platform. So this is the horizontally rotating platform, and you're holding it. How it is being held? Which orientation?
So it's like you're just holding the pen vertically above, just about to drop it on the rotating disc.
No. It's saying that at a distance r from the center of the platform.
Yes, sir. So it's like it's at a distance r, and you've held it vertically. Right. Just if you release it, it'll stand vertically on the platform.
Just a minute, just a minute. I'm going to draw a case. Yeah. You would say it's not this way?
That would be a horizontal position, right?
Yeah.
So
Because
there's-
they're saying R, then how will it be R? How does R qualify?
I'll just send you what I think the author means.
You have taken it this way, right?
Yes, just 1 second. I'll send you my interpretation.
I thought this R is the distance. What does that signify? Length will initially head vertically just above a horizontal rotating platform at a distance R from the center of the platform.
So I've sent you an image, if you can have a look.
Okay, got it. So you are taking it displaced by R.
Yes, sir. Displaced from the axis by R held vertically.
The axis held vertically R, and the end is touching the disc.
No, it's initially not touching. They've said just above, but then you release it. It's like just not touching. So you release it so that it doesn't gain any velocity. But I think it's what they're essentially trying to say is the disc is rotating, and you just suddenly have the rod appear.
Then will be R2 minus R1 by L, right? V2 minus V1 by L.
So
as the disk is rotating and at a distance R, is omega of disk given to us?
Yes, sir, it is.
So omega into R will be the velocity of one end which touches it. If it is no slipping, if there is no slipping, then omega into R will be the immediate velocity of one end of the rod.
Yes, sir.
And then the other end will be still at rest.
Yes, sir.
So omega into R divided by L will be omega of rod.
So, but they've asked when it reaches the horizontal position. So you've got to wait for it to topple down, and when just before it hits the ground, you've got to find its angular velocity.
Yeah. Right. So omega we got right here.
Yes, sir.
Once we got omega, then it is to rotate by what angle to topple we know, by angle 90 degree.
Yes, sir.
There is no alpha to the disk.
Yes,
there's no alpha to the disk.
There's no alpha to the disk.
Yeah, tell me.
Yes, go on. I was agreeing with you.
So omega of rod will maintain. Omega of rod will maintain, right?
So won't it be accelerated due to gravity?
Mass of M accelerated due to gravity.
So, and also, if you're considering there's no slipping, won't the disk also drag its bottom end along, accelerating it a certain way? I mean, it's also the bottom of the disk is also rotating, so there would be a certain acceleration from the bottom of the disk also. It's not moving in a straight line, so.
Let's say I'm on the disk, fine.
Yes, sir.
So I'll apply pseudo force to it, correct? Pseudo force to the rod.
Yes, sir.
And that pseudo force should pass through center of rod, okay?
Yes, sir.
Okay. So if I'm at the center, then pseudo force is not to produce any torque. So what I get, okay, I'm at the center, then pseudo force will not produce any torque, but friction will produce.
Yes,
as you said so.
Yeah.
Yeah, friction will produce. So there is friction acting. There is friction acting. So I am on the rod, I'm rotating with the rod, and then looking into the scenario. Then there are forces acting on it. Torque will be produced only by friction. Mg will also not produce any torque. Okay.
So when it starts to topple, Mg will produce torque, right? Because
no, but I'm at the center. Mg will act at the center, right?
Oh, okay. You've positioned yourself at the center. Okay.
Yeah, position myself at the center. So the only force which is to produce torque will be force due to friction.
Yes, sir.
And that'll be mu into normal. Right? Mu into normal. But as it starts toppling, then there will be one more force which is normal to produce, because normal will then get disaligned.
Yes, sir. So normal will also produce torque.
Normal will also produce torque, and they will be in the opposite sense.
Yes, sir.
Normal will be upward, and we are fine. Then it reduces this problem, Vasudev. As of now, what is coming to me, I'm trying to air it. It reduces to this problem where there's a rod given to you and it is allowed to slip. It is rotating this way. Being released on nudge, you can say, and starts rotating, but this point is at rest.
Yes, sir. Could you explain the situation again?
Yeah, there's a rod given to us, okay?
Yes,
and rod is left at this position theta.
Yes.
Okay, what time will it take to hit the ground?
Okay. So the bottom is fixed.
Bottom is fixed. Enough friction so that the bottom doesn't.
Yes, sir.
So friction will act in this direction, Fx.
Yes, sir.
Will act in this direction, normal.
Yes, sir.
Okay. Then we write two equations. The acceleration over here will be in this direction, that will be AT, and acceleration will be here in this direction, it will be AR as well. Okay, as omega is changing.
Yes, sir.
So we write Newton's law of motion. Fs is equal to how much? Force is equal to mass into acceleration of center of mass.
Yes.
So m into one of the component. If this is theta, this will also be theta.
Yes, sir.
And this is theta, this is theta, this will be 90 minus theta, correct?
Yes, sir.
M into 80 cos 90 minus theta will be sin theta minus AR into cos theta. Check it out. This is first equation. Okay?
Yes, wait 1 second. 80 sin theta minus AR cos theta. Yeah, it's okay.
Got it?
Yes, sir.
Second equation for 80, what we can write? 80 tangential acceleration. Now I'm coming from A is equal to R alpha, okay?
Yes, sir.
So L is how much to you? L by 2 and alpha is alpha. So 80 is equal to L by 2 into alpha, okay?
Yes, sir.
Okay, now the torque equation. Torque equation, what do we get from here? mg L by 2 sin theta. mg L by 2, this is mg, this is L by cos theta. mg L by 2 cos theta, right?
Yes, sir.
Torque, normal will not produce any torque, is equal to what to us? Is equal to I about that point, IP into alpha.
Yes, sir.
We got the equations, correct?
Yes, sir.
Okay, now what we can write? Fs to be, one more equation, Fs should be less than or equal to mu into normal, right?
Yes.
Et alpha we have, alpha we can write in terms of d theta by dt, so that I'll do later. IP is known to me. What are the unknowns from here? The unknown being AT and AR, correct? Where
yes.
AT is also in terms of alpha, AT is nothing but L by 2 into alpha, correct?
Yes, sir.
Now, if we are able to relate to omega, which we can do two ways, one is by energy. Energy will be easier over here. If we assume that it started from certain position and now it is already rotated by certain position and at energy, then energy can be related to omega. There is no loss of energy, correct?
Yes.
Initial energy, let us say if initially it was 0, now it is having omega some point in time.
Yes.
Okay. So initial, what was the tiltation? Minus of mg. If I take the total rod to be initially placed, so minus of mg L by 2. Oh, sorry, plus of mg L by 2. This point being taken as 0 potential energy.
Yes, sir.
Okay, is equal to, if it is rotated by an angle theta here, then 90 minus theta. So mg by 2 cos of 90 minus theta will be sine theta.
Yes, sir. Yeah, that makes sense.
And plus of half ip into omega square, right?
Yes, sir.
This gets us omega. Okay?
Yes, sir.
This gets us omega. Now we were to calculate. Yeah, tell me.
Sir? So no, it was my dad. Continue.
This gets us omega. When we get omega, we get alpha as well, right? Yeah.
Yes, sir.
And from here, then we can relate. Because alpha was unknown. AR was to be related to AT. We related AR to AT, correct? AR is equal to what to us? Omega square into L by 2. Correct?
Yes, sir.
And alpha, AT was in alpha, and alpha got related over here. From here, we got alpha in terms of omega.
Yes, sir.
So we get Fs over here.
Okay, so we get Fs. So from there, how do we go to finding its angular velocity at the bottom? Do we just use the energy equation?
We can use the energy equation because there is no loss of energy.
So, but there is a constant torque being applied by friction, right? So we have to account for that.
That is not doing any work, right? There is no drag. You need to say energy being in rotation use. Is it so?
Yes, sir, because the disk itself is rolling, right? I think they've given a radius r from the center for a reason, because we'll also have to take into account the curvature the friction will take while it's rotating.
But let me, where is the loss? That is incorporated in omega. Omega will increase. So we are taking alpha. We are factoring the work in terms of rotation.
Yes, sir.
There is no loss.
Hmm.
That work is being utilized. Else we will not be able to use this equation.
Yes, sir.
I'm getting omega. Rotational kinetic energy is increasing.
Yes, sir.
Work is being done, no doubt about by friction, but that is going in increasing the rotational kinetic energy. There is nothing which is getting dissipated.
Yes.
So there being no rub.
Yes, so I think I'll take this to. Sir, go on.
What is coming to me as the first thought is there will be no loss. It will be conserved. Energy will be, work will be done by friction, but energy will remain conserved.
Yes, sir.
That is what is making me go ahead with this equation Fs. And if Fs is at all being asked, then Fs can be equated to normal, but I don't think that will be required because we have taken energy to consider. See, there are two ways of getting omega. One is by getting energy equation directly, and the other is by getting force equation and torque equation.
Yes, sir.
Both gets us omega. There are two ways of getting it. In any problem which we solve, for example, this problem that we solve, there are two ways of getting omega. One is you write the normal equation and then write torque equation, that integrate, you get omega. Second is by simply conserving energy about ICR, instantaneous center of rotation, that also will get you omega.
Yes, sir.
So I have written over here all the equations. Either you get omega by this or you get omega by this. Once omega is gotten, then we know alpha, and then we can get what will it be when it hits. Due to defaults, I need to check and then we'll get with the answer. Have you tried this way out?
So no, I didn't actually delve this deep into a solution. Initially I didn't know how to approach it in the first place, but now I think I'll take some time to explore all these new avenues.
Why are you saying that energy should not be conserved from your coming? Where from it stems? May I know?
I don't know. So my point was, if this was a rod and it was just let to topple over a surface, let's say, then I think you could say that energy would be conserved because. I mean, even then, okay, let's consider this a simple scenario. There's a rod, you place it vertically, it's falling down over a table, right? And then there's friction acting on it, and the friction is such that it does not allow its bottom end to move.
Mm-hmm.
Okay, the friction keeps its bottom end fixed. So in this case, does friction do any work while keeping its bottom end fixed?
No, friction is not doing any work. And normal, when you're talking of the area, that normal per se is changing. That normal will not remain the same.
Yes, sir.
But point of application of normal is not moving.
Yes, sir.
So if the point of application of force is not moving, then how will that force do work?
Okay, so we're using that kind of arguments. In F dot ds, there's no ds, so no work.
There is one catch in it, which is what? When you talk of center of mass of this position, center of mass is moving.
Yes, sir, that was my question. So, do we consider the point of application or the center of mass?
Yeah, that's a very good question. We never consider point of application solo. We consider center of mass.
Yes.
So for this body as a center, because you must have solved question with this string, and then when you talk of normal there, what will be work done by normal? We can't say work done by normal acting on the bottom block will be 0. Why? Because the center of mass of entire system do move. So work done will be by the center of mass.
So your voice is breaking. Could you repeat?
Work done will be taken by the motion of center of mass, isn't it?
Yes, sir.
Because you are referring to the body, you're not referring to a point.
Yes.
So in this case, if we are to take normal, and normal is acting, but the rod center of mass is moving. Center of the mass of the rod is moving, or it is getting collapsed.
Yes.
Then work done by normal certainly is to be accounted.
Yes, sir. So if there's an external force doing work, how can we say energy is conserved? I mean, energy is conserved, sure, but we can't say initial energy is equal to final energy.
How perspective altogether. Let's say that there is a ball which is rolling down the inclined plane, correct?
Yes, sir.
And force is acting at the bottom, right? Bottom is not slipping, correct?
Yes.
So what we say, work is not done, certainly work is done. But what aspect is to be seen? Work will increase omega, right? As the body is moving down, omega will keep on increasing. Down the inclination of the body is moving, then omega will keep on increasing, yes or no?
Yes, sir.
Omega will keep on increasing. For example, this one over here. What is friction doing? Omega is increasing. Omega, one aspect is omega being increased by friction. Of course, omega will increase, no doubt about it. And friction is the only force that can increase it. Mg passing through center, normal passing through center.
Yes.
So friction is doing work.
Yes.
But net work done by friction, what friction is also doing is it is decreasing V.
Yes, sir.
Okay, so net work done, when it's checked, it will be 0.
Okay. So ultimately what you're saying is, although the point of application of force motion doesn't account for the internal changes in energy, ultimately you can say that the change in energy of the system is 0 if the point of application does not move. Because here the point of application does not move, see.
Doesn't move, right.
So even in a rod collapsing situation, we can say that since the point of application isn't moving, friction isn't doing any work there, although it might be changing the distribution of energies inside the system itself.
Yes. Yeah, correct.
Yes.
Normal will also keep on changing, right?
Yes, its translational versus rotational velocities will change, about its center of mass at least.
Yes. That is essentially the argument.
Yes, sir. And so I had another question. You sent me this contact on WhatsApp. I was a bit bewildered. What am I supposed to do exactly?
What did I send you? Remind me of it. I keep on sending. What did I send you?
So he sent me the contact of some person called Amit Anand.
Oh, right. Yeah, remember you asked me a question about how can you get your long back?
So could you repeat? I'm sorry, your voice is all over the place.
You asked me looking at the status that you're interested in this course, how can you make an approach, right? Something long back.
Yes, I think that was for the IOI exams. There's a pretty fast approaching now in a couple of months actually.
And is this not the same? So it was in that context only. This Amit is our student even. And he what to do. So he only did pass on that message. I have passed on your information, and by your information I mean your profile information to him, and he would like to be in touch with you. He can be a great help. He's out there, and he is, I would say, one of the leading figure with Waterloo, and the other one is with Alberta. So whichever you want to be help on, I think both are on, and both are easily approachable.
Yes,
So
sure.
Chance, then you can work, and he will help you with whatever in the past. That is a sure.
Yes, if I do have any doubts pertaining to this, I'll be sure to approach him.
Right?
Yes. Could you please repeat?
First, one you applied for other, and he said that there's something got rejected or something.
So I still can't understand what you're saying.
That is in the month of July, dear, not in the month of January.
Yes.
You applied to university for a course, right?
Yes, sir.
Somerset and wrong with one of the application, correct?
So last sentence again, please.
Something went wrong with one of the application, right?
Last year, you're talking about my applications to Olympiads?
Yeah. No. To the university summer course.
Ah, yes, sir. My PRMO, yes, they rejected me without any reason. I still do not know why. My submission was as good as I could get.
So at that time, you also were fancying a chance with other university, correct?
No, that was the only application I had that summer. I'd put all my work into that. Just like put all your eggs in one basket type scenario.
Exactly. Perhaps you didn't apply for the others, right?
Yes, I decided I could only work on one because that was all I had the time for back then.
Okay. So what are you to fancy this time?
I'm pretty sure I will make it across to the advanced level. So I'm pretty sure most of my summer this time will go into advanced preparations whenever it's going to come up, or June or July. So I'd like this summer to remain as unhindered as possible.
Yeah, so there is no need to get dissuaded then. And let it be there later to be taken, fine?
Yes.
Not now, not this time.
Yes.
Okay, then there's no point contacting now. Later. Okay.
Yes.
Thank you. Bye. Bye, both of you.
Yes, sir. Bye, sir. Thank you. Good night.